Welcome to the third tutorial for Wesbeam's eHouse Beam software. By now you would have familiarised yourself with the setup of the program and modified your timber list and default settings. This tutorial is going to go through a basic beam design and show you how to output this design information onto a print sheet, which can also be saved onto your PC or cloud storage and edited in the future. One of the best ways to become an eHouse Beam expert is to simply practice designing different elements and explore the effects of different inputs such as building material mass and cantilevers. eHouse Beam allows you to design floor joists, floor bearers, wall members such as lintels and wind beams, as well as roof members. Take time to go through the lists of member types available for design to see just how comprehensive the design options are. For our first worked example, we'll look at the design of a floor joist. Note that under the drop-down tab for member types, we can design anything from a basic floor joist supporting just floor loads, to a cantilevered floor joist supporting concentrated roof loads. You'll notice that when you select the member type, an image will appear on the right-hand side of the page, highlighting the location of the beam you are designing, as well as the relevant input parameters such as roof load width. In this particular example, we're going to design a single spanning floor joist supporting a load-bearing wall. By selecting the timber list, you can nominate the type of members you would like to use in this design. For this example, I've selected a range of the Wesbeam E-joists. You can now input your design parameters. Note that the span inputs are shown in millimetres. The software is also set up so it will automatically convert smaller measurements into the correct denomination. For this example, we'll use a 4.2 metre span with the joist spacing of 450mm. For the floor mass, you can select commonly used floor masses based on typical floor and ceiling configurations, or use a custom weight by manually typing a number. In this example, we'll use 40 kilograms per square metre. Remember to refer to the image on the right hand side if you're unsure of the input parameter. In this case, the roof load width is shown as the width of the roof structure being supported by the wall over our floor joists. For this example, let's use 2 metres of a tiled roof. Because I'm designing an individual floor joist, I want to have a maximum of 1 laminations or 1 beam used in this design. Click the Calculate button to begin the design. The product output on the right hand side of the screen will provide you with several options for your design. These designs will show you a percentage of the capacity of the beam used in strength and stiffness. It'll also show you the deflections, such as permanent deflections, short-term deflections, and dynamic deflections that the beam has been designed to. A value of 100% indicates that the beam has been designed to the strength or stiffness limits outlined by AS 1720.3. For this worked example, there are 2 options for the floor joist design. A 300 by 45 Wesbeam E-joist, nominated as an EJ345, or a 240 by 63 Wesbeam E-joist, nominated as an EJ240-63. In this case, I'll select a 300 by 45 E-joist, since the dynamic deflection is slightly lower, which will provide a stiffer floor under temporary load. Select the beam you wish to specify and click Add to Job. This specification has now been added to the job file. Remember to save your work as you go. To view the job output sheet, click the Preview button along the top panel. This output shows you the member parameters, the description of the design beam, and the strength and stiffness calculations in both percentage of design capacity and a millimetre value. From this screen, you can print locally or save as a PDF. To go back and edit this design at a later stage, whether it be to change a span or parameter, or to change the type of material you're designing, select Edit and Edit Calcs. Alternatively, click on the red cross along the top panel. This will allow you to delete or edit the design within this job. Note that you can design several members under each job and save the eHouse file on your computer or cloud storage for future reference.